It includes the iStream library for input or output operations. It defines the main function, the entry point of the program. It initializes an integer variables g to 0. It calculates a double variable k as g plus 13 divided by 27.0. It enters an infinite while loop or while true. Inside the loop, it checks if k is greater than 10. If so, it breaks out of the loop. It increments k by 1. It calculates an integer variable I as 3, then multiply t minus 1. However, this is scope within the loop and is not true outside. It returns 0 to indicate successful program execution. This code seems to be manipulating the variables k and I within an infinite loop, but since I is a scope within the loop and not just outside, the loop doesn't serve any practical purpose, and the program doesn't perform any meaningful operation or output.
Let's discuss the code step by step for C++ language. Initialization. We initialize a variable g with a value of 0. In calculation of k is calculated using formula g plus 13 divided by 27.0. Since j is an integer, we use 27.0 to force floating point division. Infinite loop. The while true loop creates an infinite loop. Condition check. Inside the loop, we check if k is greater than 10. If it is, we break out of the loop. Increment of k. If the condition is not met, we increment k by 1. Calculation of I. We calculate I using the formula 3 times k minus 1. In loop continuation, the loop continues until the condition k is greater than 10 is met.
Java code computes k as g plus 13 divide 27.0 and initialize g to a value. After then, it gets into an endless loop where it keeps increasing k by 1 until k exceeds 10, at which time it ends the loop. Nevertheless, I is calculated as end 3 times k minus 1 inside the loop, but nothing is done with it. This indicates that while I is calculated, it is never used. Thus, the loop effectively never ends, increasing k until it's bigger than 10 with no useful result. Let's discuss step by step. End j equals 0, initialize an integer variable j with a value of 0. Double k equals j plus 13 divide 27.0, calculates the initial value of k as 0 plus 13 divide 27.0, which equals approximately 0.481. While true, this creates an infinite loop because the condition is always true. If k is greater than 10, break checks if k is greater than 10. If it is, the loop breaks, ending the group. K equals k plus 1, increments k by 1 in each iteration. And I and 3 times k minus 1. Calculates the value of I as 3 times k minus 1 and casts the result to an integer. However, this variable I is local to the loop's block and cannot be accessed outside of it. Since there are no other break statements or conditions that can end the loop, it will continue indefinitely as long as k remains less than or equal to 10. The loop runs indefinitely, incrementing k by 1 in each iteration until k becomes greater than 10. The value of k starts at approximately 0.481 and increases by 1 in each iteration, so the loop will execute 10 times until k exceeds 10. After that, the loop breaks and the program ends. The variable I is initialized and calculated within the loop but never used or accessible outside of it, so its calculation doesn't affect the program's behavior.
This code starts a while loop that runs forever, while true after initializing k depending on the value of j. It determines whether k is bigger than 10 inside the loop and exceeds if it is. It determines a new value for I and increases k by 1 if k is not more than 10. But in the provided code, I is not utilized anywhere else. Therefore, it might not have any significant results depending on the context and the code's intended purpose.
Initialization. We initialize variable j with a value of 0. K is calculated using the formula j plus 13 divided by 27. In Python, division automatically produces a float if either operand is a float, so no need for 27.0. The while true loop creates an infinite loop. And for condition check, inside the loop, we check if k is greater than 10. If it is, we break out of the loop. If the condition is not met, we increment k by 1 using the shorthand k plus or equals to 1. For the calculation of increment, we calculate I using the formula 3 times k minus 1. The loop continues until the condition k greater than 10 is met.
Python usually performs well in terms of writability because of its clear syntax and integrated features. Comparatively speaking, Java and C++ can be verbose, requiring more lines of code to accomplish the same task. Java's tight syntax and detailed type declaration make the code easier for other developers to understand, which contributes to its generally higher readability. Python's simple and obvious syntax contributes to its high readability score. Nevertheless, in bigger code bases, the absence of explicit type declarations can occasionally cause confusion. Although C++ may be read, it
frequently necessitates a deeper comprehension of memory management and foundational ideas. It is dependent upon the particular environment and project objectives to determine the optimal balance between writability and readability. Due to its ease of use, Python is frequently chosen for rapid prototyping and scripting, whereas Java and C++ are frequently utilized in bigger performance-critical projects where the readability and maintainability are essential.
Similar to C++, Java uses while loop with the same condition. Integer division in Java also truncates, so the same caveat applies regarding j being a multiple of 27. Python uses a while loop as well as the integer division operator, performs floor division which rounds down to the nearest whole integer. This makes the behavior slightly different from C++ and Java where truncation occurs. In terms of readability, Python arguably has slight edge due to its simpler syntax. The use of double slash for floor division is more intuitive in this context. However, all three languages are considered readable for loops of this nature. C++, the while loop is used with the condition k less than or equals to 10. To continue looping as long as k is less than or equal to 10 inside the loop, the value of I is calculated then incremented k++. An important note for C++ is that integer division truncates the result, so j must be a multiple of 27 for k to ever be less than or equal to 10. Python is known for its readability due to its clean and expressive syntax. It often considered more readable compared to C++ or Java. Both Java and C++ can be readable, but they might have more complex syntax and require more attention to detail compared to Python. Java's verbosity model is slightly higher readability compared to C++.
Initialization. The variable k is initialized with a value of 3. The variable j is declared to store calculated value based on the condition. Switch statement. The switch statement evaluates the value of k and executes the corresponding case. For k, values of 1 or 2, g is calculated as 2 times k minus 1. For k, values of 3 or 5, g is calculated as 3 times k plus 1. For k, value of 4, g is calculated as 4 times k minus 1. For k, values of 6, 7, or 8, g is calculated as k minus 2. The default case is included for handling values of k that do not match any specified case. The calculated value of j is printed to the console using stdcout. When the program runs, it evaluates the value of k using the switch statement and assigns the appropriate value to j based on the conditions. Finally, the calculated value of j is displayed on the console.
The switch statement works similarly to the C++ version, checking the value of key and executing the corresponding block of code based on its value. Each case represents a different value of key, and the corresponding action is taken. The default case is included to handle any other values of key that are not explicitly listed. First, we declare the variable key and assign it an example input value. We declare the variable j without assigning a second value yet. We use a multiple selection statement, the switch statement, to evaluate the value of key. Inside the switch statement, we have different case levels corresponding to the possible values of key. For each case, We assign the value of j according to the given conditions. We use the break statement to exit the switch statement after each case. The default case handles any invalid input by logging an error message to the console. Finally, we output the value of j to the console using console.log.
The variable k is set to the value 3, which serves as an example input for conditional checks. The variable j will store the calculated value based on the conditions. The code uses if, elif, and else statements to check the value of k against multiple conditions. If k is equal to 1 or 2, the value of j is calculated as 2 times k minus 1. If k is equal to 3 or 5, the value of j is calculated as 3 times k plus 1. If k is equal to 4, the value of j is calculated as 4 times k minus 1. If k is equal to 6, 7, or 8, the value of j is calculated as k minus 2. If k does not match any of the specified condition, j is assigned none. The calculated value of j is printed to the console using f strings formatting to include the value in the output message. When the code is executed, it evaluates the value of k based on conditions specified in the if, elif, and else blocks. The appropriate calculation for j is performed based on a condition that matches the value of k. The final value of j is displayed on the console. We replace break statements with conditional statements to control the flow. In the case where j plus 2 is either 3 or 2, we decrement j. If j becomes greater than 0, we set j to either 0 or 2 depending on its value. In the case where j plus 2 is 0, we increment j by 2. If j becomes greater than 0, we skip the rest of the loop iteration using continue. We maintain the same logic for handling the default case and breaking out of the loop with j becomes greater than 0. Finally, we adjust j at the end of loop iteration based on the value of I. The program finds the final value of j after the loop execution. In the original code, the switch block and the for loop were terminated using break statements. In their place, we added goto instructions and levels. Check J to enable us to continue the loop at particular location without exiting it completely. Although they can make code more difficult to read and maintain, goto statements can be used sparingly when breaking out of nested loops and required without adding extra complexity. The revised code is arguably less readable than the original, even if it accomplishes the objective of eliminating break statements. Achieving a balance between code readability and programming guidelines is crucial.